So we're here with Rudy from Emerson NI. So he's going to talk about his background and some of the development of NI's products. So Rudy, maybe you can give me a background of your tenure at NAI. I believe you started as an FPGA engineer, and then you've obviously been to have other positions here. Now you're heading some of the company's product development. So maybe you can tell me about that first.
Sure, yeah. So Rudy Sengupta, Vice President and General Manager of Emerson's Test and Measurement Division. My focus today, as you mentioned, is on software, specifically test software all the way out to enterprise level analytics solutions. But I started at NI around 20 years ago, a little over 20 years now, as an FPGA developer, focusing on our Compact Rio product line, which line was brand new at the time. And I had an opportunity to be on the founding team of that product. Really exciting time for NI. Developed a lot of the C-Series I/O modules. And then I moved into management. I managed multiple R&D organizations like Vision and our R-Series product lines and our sound and vibration hardware and software products. Eventually moved into product management. Again, I've probably managed 80 to 90% of our overall software and hardware portfolio at NI. And then eventually I took on more strategic roles. I was even chief of staff to our previous CEO during the acquisition as well, which was an interesting time for NI. And now, as I mentioned, Vice President and General Manager of NI's software division.
So that 20-year period, so that would date back to like the early 2000s. So in the mid to early 2000s, that was probably after the dot-com era. They just started seeing the development of mobile phones. So what are the changes you've seen in electronics since then, particularly from NI's perspective? Back then you started with FPGAs, which were, I guess, relatively new at the time. What are the changes you see in hardware and software? And maybe you talk about like the LabVIEW. Obviously been around. It's been around for a long time.
Yes.
How has that evolved in the time you've been here?
Yeah. So you're absolutely right. Incredible amounts of innovation and evolution of technology in the last 20 years since I've been here. I started in the mid 2000s, and as you correctly pointed out, LabVIEW has evolved quite a bit since then as well. So what I've really seen is the staggering increase in complexity, right? So semiconductor devices were these two-dimensional devices, right? That you had chips and transistors laid out on a plane. Now there's so much more complexity. You've got systems on packages. You've got heterogeneous computing systems, and then even beyond semiconductors, you look at the automotive market. ECU technology, cars are now getting more and more electronic, very little mechanical components still remaining in there as you keep going forward and into EV era. So this incredible increase in complexity has driven a lot of innovation, and actually has required us to evolve as well. As you mentioned in LabVIEW, LabVIEW started out as a graphical programming environment, and since then we have worked on real-time systems. We've added the ability to program compute elements like FPGAs directly in LabVIEW, making it easier for scientists and engineers to program complex devices like LabVIEW. And we've continued to invest. The need to be able to, in order to actually tackle this complexity increase we've seen, there's been a significant need for abstraction, which is how do we enable our customers to not have to be so deep into the technical details and learn all of this capability for them to leverage it. How do we abstract that complexity and accelerate our customers' job? And that's what we've really been focusing on with LabVIEW, as well as the LabVIEW Plus suite, which is a collection of application software that allows our customers to get up and running fast.
Yeah. And leading up to development of AI, how have the company been able to get the skill sets in order to learn and develop these new technologies? Because some of these technologies, these cutting edge technologies, are not necessarily things you learn in school. They're probably things you kind of develop. Your engineers have a lot of expertise, but they may not know this stuff initially. How was the expertise developed and honed over the years?
There's some core tenets of our platform that have really helped us evolve and embrace this AI technology inflection that we've seen. Our platform was designed to evolve and grow. Luke talked about that today in the day 2 keynote of NI Connect at Fort Worth this week, which is the platform started out as instrument control, and we've now, of course, evolved to take on really, really complex applications. And that has really helped us in this AI era where being founded in this open, flexible architecture in our platform has enabled us to embrace new technology like AI. And to your question, our engineers, brilliant, very, very smart, very capable engineers, but this is a new era for all of us, and we have a deep learning mindset amongst our engineering teams, and they've been doing a lot of training, a lot of self-taught, just kind of playing with this technology, but also a lot of kind of structured curriculum courses that we've been kind of developing internally to get people ramped up. And frankly, the other thing that has been a really big learning experience for us is the appreciation for the customer's job to be done, right? What is their job? What is their largest areas of friction or where their productivity is getting hampered? So we've been actually recruiting a lot of people to work on our products that actually are from these industries like semiconductor, automotive, aerospace, defense, so that we understand what their jobs are, and we can then bring that capability into our platform to make sure that we can, again, accelerate the work that they do.
So your workforce is really multidisciplinary. It's not just people who were coders or anything like that. It's from people maybe who have engineering, hardware experience, maybe some software experience in some of these industries that you serve.
Absolutely, yeah. And a test engineer's job is a pretty complex job, and coding is frankly a relatively small subset of that job. And now with general purpose large language models, is becoming an even shorter and less complex, more commoditized portion of what they do. But as I talked about with this increase in complexity, what's actually happening is the work that they have to do up front, creating a test strategy, understanding what test system they need to build, the hardware, the software that they need to actually even assemble, IP they need to assemble before they even start writing new code is more complex. And then the later part, which is after they've done the actual measurement gathering, it's the insights that they need to get from that data, because you're just generating so much more data with a more complex device under test. That's adding a lot more complexity too. So having that, exactly as you said, a multidisciplinary team, a team that understands all of the work that a test engineer